Hey guys, welcome to the Reliable SRE Podcast. Today we have with us Mr. Robert Thomas Zamora, a seasoned professional known for his expertise in DevOps and networking. With a substantial background in the IT industry, Robert brings a wealth of experience to our discussion, and I would love to hear his thoughts. Having said that, welcome to the podcast, Robert. I trust you're doing well. Could you maybe tell us a little bit more about yourself?
Sure. So, very thank you for the invitation. It's always good to talk about reliability topics, and it's fun to be here with you guys today. How did I start it? Well, I started a little bit over 10 years ago. I started working very early. I started working for Cisco around when I was 18. I joined the Technical Assistance Center. I started first doing unified communication support for the Cisco TAC. And the thing with unified communications is that they're very critical systems, right? People don't want their phone systems to be unreachable or unavailable for emergencies, for contact centers. So it's one of those systems where they stop. People basically go running around with their hands in the air. So that's a little bit how it started. That introduced quite a bit of things that were new to me, things such as high availability, clustering, distributed databases. The solution that Cisco had was quite interesting. Gradually, I transitioned from a telephony world, which is a little bit of a niche, more into the data domain. So I began to do a little bit more network infrastructure, because when the network breaks, the first thing to complain is always the telephony. It's one of the most sensitive data that travels through the network. So if you get congestions or packet lost, is the first one to get affected most of the time. And eventually that led me more into the ISP world, where basically you need to be online 24/7. And as more outages escalating to bigger outages quite quickly, and usually within 3, 4, 5 minutes of an ISP being disrupted, everybody knows. So customers need to get answers. Backup plans needs to be put in practice. Technicians needs to be deployed to the field. So there's a lot that is happening in the telecom domain. And over time, what you tend to see is that hardware tends to become more abstracted by software or replaced by software. And you start putting high availability concepts that allow you to maintain systems running for longer. Things like vMotion or live motion for virtual machines and other things. So software plays a role in making systems more available, cloud, multi-cloud deployments. So I started to get more involved into writing code, automation, things like that. And then eventually I transitioned to my first proper DevOps and SRE role. I moved from Costa Rica to the Netherlands at that point. I went back to working for telephony, but this time in the cloud with a lot of programmers and developers, and putting a lot of concepts that Cisco use at the same time. But Cisco was an on-prem solution, so a bigger scale, because now you have a single platform and you're serving hundreds of thousands of customers. But a little bit of the architecture is the same. From there, I move a little bit more into finance, a different view on high availability and site reliability. So I've been doing hot seat and reliability jobs for a long time. That's a little bit of my background. Nowadays, I'm more into cybersecurity. So I took a little bit of a step back for reliability in the last year, but there's a topic that is still very close to my heart, and I still very, very much follow what's happening on the industry.
Out of all of the things that you've done, what did you enjoy the most? Was it writing code? Was it the DevOps part? Is it the cybersecurity part? Which one?
Well, it's a difficult question because everything has its own merit. So definitely cybersecurity it's a fun area because you need to know things in depth and you need to be able to break it and prevent to break it. And it's always a cat and mouse game. It's a little bit of a like a arms race. But I think another thing that I really like was networking, the physical side of it. Like when you're interacting with the physical world a lot more. So for me, software is sometimes a bit too abstract. So for example, one of the biggest challenges that telecom companies have is just continuous flow of electricity. And it seems like a simple problem. It's sort of solved. Most data centers solve it, but still is a big challenge, right? You need diesel generators, you need UPSs, you need proper maintenance, you need overload control, you need fast switchovers. It's a lot that goes on. And when you don't have a single facility, but you have, let's say, 100 facilities through the whole country, there's a lot of maintenance that goes into that, and there's a lot of thoughts that goes into that. And then you start seeing interesting things like battery systems, alternative systems to do energy. So it's just one component, but making sure that it's flawless 24/7 across multiple areas. And if you got thunderstrikes or other things coming, that how to manage that real world entropy, is very interesting.
What would you say is a skill set or a foundational skill that I would want to have to get into this world of networking, SRE, DevOps, whatever it may be, say cybersecurity. Feel like all of these are tied together. So what would be that one foundational skill you would suggest I have?
One of the first things, and this might not be a popular opinion, is that traditionally SRE and cybersecurity domains, they require some previous experience. It's usually not the field that you break right out of school, or you break through a boot camp or certification. There's a lot of demand, so there might be people that are hiring like straight out of school, but usually in these fields you need to have some previous domain that you already became sort of an expert on. System administration, network engineering, programming, or a domain that you basically went deep into. And then you're able to look at best practices, bad practices, where people made mistakes, how those mistakes could be abused, how they could be protected. So you could play on both sides of the fields, on the red side or the blue side. So when I see developers, I tend to see two kinds over time. People that write code and they contribute to larger projects, or people that maybe write smaller projects and they operate it to a well part. Either, let's say you host your own blog and you need to go through the whole setup of your Linux system, how you do backups, how do you do updates, how do you push out new versions of WordPress, how do you patch. Traditionally, people that tinkered a lot with infrastructure and hosting and applications, they learn a lot from running system and things that you need, then monitoring, how it goes wrong, troubleshooting. And at some point, those people might go more into traditional system administration. And then there's some developers that are not so interested into that, and they stay more in the software domain and they let other people take care of running their systems, or other platforms that are a lot more abstracted. So I think if you spend some time into the operating part, how that all works, that will give a very good foundation for cybersecurity or DevOps or SRE. Because basically what SRE is about, a part of it, is you have a large set of infrastructure and you need to somehow use code and automation as a leverage to be able to operate and maintain this large infrastructure at scale. So you cannot do it box by box anymore. So you need playbooks to do it, and you need pipelines to do it. And that means you need Ansible, or you need Terraform, or you need Python, or you need some kind of scripting language to unify your fleet, to maintain it, to update it, to monitor it, to keep it running, to extend your fleet. And at the same time, you deal with failure, right? Because you have a large fleet, you're going to have failures very often. So how you deal with that failure, whether you replace a machine for another, or you have a scalable set, or you have containers, or you have an HA system that moves a floating IP around, or whatever, any of those strategies, that will try to be somewhat automated and scripted. So basically, that's what DevOps and SRE are doing to try to keep the machine running. So it's an extension of sysadmin using tools from the software development domain, but you need to have a foundation of sysadmin and operating besides your software development set to basically be successful in this field, I think.
For the viewers who don't know what the difference between SRE and DevOps is, in a brief description, how would you differentiate between them?
It's a little bit of a historical and philosophical debate, and you could argue if they're different or if they're the same. Basically, historically, you had developers on one end and you had operators, sysadmins on another end. There were two silos. One would produce the code, they'll ship it across the board, and then the other guys would operate it. And there was a big barrier between the two. So you would tend to build releases and push them in a schedule. That schedule could be every 4 months, every year. So your release cadence was very little, and your change of the release was massive. Also, a lot of the products were hosted on-prem at this point. So you, as a company, you will build a product that people would then operate in a different platform. So it was not the same platform. When SaaS became much bigger, usually these teams end up being part of the same company, but there were still two teams. So you have your traditional push on SAP every 3-4 months, let's say. What you're trying to do with DevOps is to go faster, so you can do more experiments. The experiments can be smaller, they can be less risk, so you need to deploy it often, which means you need a lot of things aligned for that. You need to have testing, you need to have pipelines, and your developers basically operate your platform. So you will have now, instead of having developers and ops, you have engineers that are sort of doing the whole mile, where they're doing development and they're doing operations and they're taking the feedback from operations back into development. But usually within this, you will still have some people that are even a bit more specialized on the ops side. So are people that are able to write code, to do operations, to produce pipelines, to interact with the developers, to have storyboards, points along with the developers, contribute to the code base, but they're a bit more focused on the operational side, because there's specific tooling that they need to know about that you cannot do the whole scope when you're in a massive infrastructure. So that's usually what we call DevOps or DevOps engineers. Now, SRE is basically sort of similar concept. It was developed at Google initially. So Google basically had some developers that were more operationally focused. It was their best developers. So they had around 1,000 of them worldwide. And they were transitioning to an organization called SRE. And what the SREs would do is basically making sure that the biggest products stay alive. They were successful. For that, they needed to write code. They needed to do metrics. They needed to write a lot of development to maintain these products within a certain error budget, right? So the products will have limits on the amount of downtime they could have, the amount of errors that an API could get back, or different things. So this is basically what people call SLAs or SLOs, like service level objectives, service level agreements. So when you have a mature product, you can have a lot of developers and just one SRE, and then the SRE is able to maintain all the product within the service level. If the product gets a lot of features and the quality and the maturity of the product degrades, and then you're not meeting your agreements, the SRE is not able to maintain the product anymore. So he gives the product operations back to the developers, in which the developers needs to go in, focus for some time in just operational issues, fixing stability bugs, adding additional metrics, observability. And then once the product is again within budgets, then they can move it over to this SRE to do the operations for the product, let's say. And then when you get new products, usually is a new product, is starting up, is being explored by developers. There's a lot of change and the product's not very stable. Then at some point the product needs to get through an approval process to become production ready, and then you could get assigned an SRE that would operate your product, right? So teams like to have SREs because they can shift a percentage of the operational work towards the SRE. So the SRE is a little bit of a DevOps engineer that is a lot more focused on metrics, SLAs, SLOs, and it's a figure that started within Google. At some point, Google wrote a book, it made it public, and more companies started to sort of copy on that, let's say, idea. The issue is a lot of companies copy it wrong, right? So sometimes you have reliability issues, and then you take engineers, you change the title, you turn them into SREs, but the culture is not there completely. So you don't get the same results. At the same time, the challenges that a lot of companies have are very different from the challenge that Google had. So the skill set doesn't necessarily translate one-to-one.
According to you, what are the primary guiding principles that a company intending to, say, establish an SRE department should consider?
I think for me, the biggest thing, or where it all starts, is what cannot be measured cannot be improved, right? So you need to have measurement in place. You need to have observability in place. You need to have metrics in place. And you need to know your baseline. Because you need to know how your platform operates in a good day and what's the expected boundaries. So when disaster happens, you're able to fix it fast. And ideally, you're able to tell when things are going south before it gets too late.
That's a great point.
The other aspect is when you have issues, you need to be able to do root cause analysis properly without pointing fingers, without doing blame game, to be able to understand where are the weak spots of your infrastructure to prevent those issues from happening again. And usually when there's a big incident, the findings or the learnings from the incident won't fix within 24 hours or 48 hours. It will usually be items on the backlog that take a long time to get addressed.
What would you say are the pros and cons of cloud environments versus on-prem environments?
Well, definitely there's a lot of pros in cloud environments. I think the biggest difficulty or the biggest con of cloud environments are cost. Because if you know what you're doing, on-prem environments will always be cheaper after a certain scale. So let's say you have 1,000 hosts plus, and you have a team of 8 engineers. From that moment on-prem will always be cheaper if you're doing it right. Because your managed database costs are very expensive per hour, your storage is very expensive per hour. So if you compare your bill will be 2 or 3 times more expensive if you're doing everything cloud. Now, back in the days when money was cheap and you were able to get a lot of funding and you were a startup and you could justify just to run everything on cloud for a long time because you were just doing business and getting larger and going to market, sure, you could argue that overspending on your infrastructure is a cost of doing business. You're going to do more sales to pay for that bigger cloud bill. So that's on the downside. On the upside, there's a lot less things to worry. In the sense that if a machine dies, you spawn a new one in another availability zone and it's there. If you want to replace the server, it's a 24-hour replacement if there's on stock or there's a 5-week leeway. So you need to manage your inventory a lot more better on-prem than what you do on the cloud. The same thing for capacity management, right? on cloud, you're able to just get a lot of additional capacity. You do need to do your capacity planning a bit better because it goes back to cost. If you do it too much, then your costs break. If you don't do it enough, then you get incidents. But usually you can expand and contract the size of your infrastructure a lot easier. And the whole infrastructure as code is much easier done in the cloud, which means you can also have more environments, which means you can also have more experiments. You can have better DTAP, which means maybe you have less bugs if you do proper development and testing. So all those things are not given. You still need to work for that, but it makes your infrastructure a lot more flexible and easy, at the benefit that you're spending more that you would do traditionally. So depending on the size, it might matter or not, but I think that's the biggest thing. One of the things that is nice about cloud is that it's very easy to set up an infrastructure in 2 different availability zones or in 2 different regions. If you wanted to replicate or do the same thing on-prem is a lot harder, right? You need a lot more investment to have 2 proper data centers or 3 that are completely separated, different stacks. In the cloud, you can have that very easily. Now, at some point, the architecture gets tricky because you now need to start thinking about replicating your data, replicating asynchronously, making sure the replication is happening properly so you can move from one region to the other. So there's also complexity there. You could argue how easier it is to have a DR and a HA setup if it's on-prem or cloud. Some people will swear by the cloud version. Some people will swear by the on-prem version. It's in the eye of the beholder a little bit.
Talking about clouds, what have you worked with? What do you prefer out of the big 3?
Well, to be honest, I've never worked much with Google Cloud, so I don't have a very good view on GCP. It's mostly external. I work quite a bit with AWS. Most recently, I've been working a little bit more with Azure. The pattern that I tend to keep going the most to is Terraform to spin off infrastructure, and then Ansible to do deployment on top of that. So the actual cloud that I'm using is not so important. For my own personal projects, I tend to use simpler suppliers like Vultr or DigitalOcean. They tend to be fine for a very small project.
That's great. So I think with that, we'll be ending this episode of the Reliable SRE podcast. Thank you, Robert, for sharing your valuable insights. It was a truly enlightening conversation, and I would love to reconnect with you in the future.
It's been a fun talk, and we can always expand in the future and dive deeper into a specific topic. So if there's a certain follow-up or topic that you would like to see more discussed, maybe you can add it in the comments, and then we'll look into it and have a follow-up discussion in the future. Thank you for having me.
Sure. Thanks a lot to all of you watching. Have a great day ahead and see you.